Okay, hi everyone. Are you able to see my screen now? Yes, I think so.
Give us a second. Yes.
Okay, great. So yeah, as Hila said, I was not able to make it to AoM. My brother just got married in France, so we've had a beautiful few days here, but at least I could join you virtually. I think this session seems to have worked really well as a hybrid session. I think we have 66 people in the Zoom room right now, which is pretty cool. So I'm going to provide some notes essentially from an ongoing research project that I have. And I call this Navigating Algorithmic Environments. And the subtitle here, as you can see, is a study of internet spaceships, because this is in the context of video games. And the core of the study is centered around this idea of an algorithmic environment. And in my understanding, an algorithmic environment is a digital space where the set of agents and objects that show up is algorithmically determined, or at least influenced, and where the characteristics and behaviors of those objects and agents are also algorithmically driven in some way. And this could be driven by machine learning algorithm, it could be driven by simpler algorithms, but they're not static. And we encounter these environments all the time, and obviously the previous speakers have already mentioned a few of them. So for example, your Facebook feed, it shows up a particular set of posts based on your network, based on what you've looked at in the past, all driven by a set of algorithms that computes a particular environment for you to experience. As Hila just mentioned, we see similar things when it comes to Google. When you search for a particular item, it will curate a particular environment for you to experience with regards to different types of objects, different types of items that it will show only you. We see this also in commerce. So for example, if you're a merchant or a potential buyer on eBay, you're also experiencing an algorithmically managed environment where the search results that you are presented with are algorithmically determined. And as a merchant on eBay, you'll also see that the opportunities you have to make a successful business are highly influenced by how your scores are calculated based on different actions that you take as a matter of course of business. We also see in stock trading, for example, that the environment that a trader works in today is not only sort of an environment where he or she interacts with other human traders, they're also interacting with bots of various kinds that are trading and therefore shaping the overall trading and market environment that they conduct their business in. This is just an example on the screen here of one such trading bot that is used to trade for stocks and other items of value. Moving a little bit closer to the context of my study, here you're seeing a screenshot from a video game that I've studied with a number of colleagues called Ghost Recon Wildlands. This is a fictional version of Bolivia, and what you're seeing is a map that's procedurally generated. Across this map, various military units move according to various algorithms, and the different types of experiences that you can have in this virtual world are based on how you interact with these dynamic actors driven by various algorithms. In video games, the micro level interactions that you have within a particular environment is obviously also algorithmically driven. The way agents in that environment interact with you depends on how their algorithms are specified and how you as a player interact with those algorithms. Further, different agents in the environment may also interact with each other, thus creating emergent behaviors of various kinds that you as a player interact with. And while we have seen virtual worlds such as Second Life for a fairly long time, with the sort of rise of cheap virtual headsets, we're seeing the rise of the Metaverse as an idea. This, for example, is Facebook or Meta's Horizon Worlds, which is a virtual world where human beings interact with each other, but where there are also various types of scripted behavior of agents and environments in different ways. So what's interesting about these different types of environments is that, and this also sort of harkens back to what Joe was saying about how AI is used in law, is that the way the environments function is often opaque and is constantly changing, so it's dynamic. So navigating these environments is a practical challenge for individuals and groups, whether it's a video game or whether it's a stock market trading environment, or where there's just someone who is trying to understand the information that is flowing at them in their Facebook feed or through the Google searches that they're doing. So I'm trying to understand, how do individuals and groups experience and navigate such algorithmic environments? So I've been engaged with a massively multiplayer online game called EVE Online. And this is a game that's often regarded as one of the most complex of all such games. For those of you who are a little bit familiar with gaming, this is quite similar to World of Warcraft, but it's set in a science fiction setting with spaceships in the future, etc. And this is a game that's often referred to as a sandbox game. And this term sandbox is trying to capture this idea that the company providing the virtual world, they provide an environment with various actors in it, but then human players come into that environment, they interact with it, and they do what they want with it and create their own experiences. And I'm in the middle of an ethnographic study. It's been going on for the past 2 years. I'm following along 2 different player groups. So in the evenings and the late afternoon, I sit on comms and I talk to them. I fly in space, in internet space, so to speak, with these people, and engage with the activities that they are battling with other corporations, trying to understand how they engage with the game. Right? This is a screenshot of the game. Most of the time, you're flying a ship in space, and you're trying to navigate an environment filled with non-player characters. It's filled with game mechanics of how different parts of the world works, and at the same time, you're engaging with other players of opposing corporations and groups who wish to harm you in various ways. Now, this is an enormously complex environment for the players, and there's lots of things that is going on behind the scenes that they cannot fully understand. Why does this part of the world work this way? Why are these non-player characters functioning the way they do? And other players can take advantage of those game mechanics to gain the upper hand in various conflicts existing in the game. So to manage this massive complexity that they're experiencing, they've designed a number of third-party applications. So this is an open source software called PIFA, and it's written in Python. It's the Pi, and it's called a fitting assistant. So this is a tool that they use in the game to design specific ships. So what they do is that they take one of hundreds of ship hulls, and they fit that with a combination of thousands of different combinations of modules of various kinds, guns and lasers and armors and shield and all of these things that you have in a science fiction world. And then this application provides comprehensive analysis of how this particular ship will be able to perform in different types of situations. And I'm not going to go into details, but you can see various parameters and statistics in the right-hand panel of this picture. So it's a fairly complex piece of software that they use to analyze the artifacts that they build for engaging with the video game. Similarly, the physical, I'm using air quotes here, environment that they encounter, the different star systems that they travel between, is also very complex and is dynamically changing all the time. So players have designed third-party applications in order to manage and understand how the star map, the environment that they live in, how it changes over time. So this, for example, is an application called Tripwire. and is used to map out how different systems are connected to each other and how those system connections change over time, so that they can figure out the best way to travel to different parts of the space. So what I've found as I've been engaging with this algorithmic environment is that one of the prime experiences that the players have is that of persistent instability. The game environment and the behavior of agentic artifacts in the environment continuously changes. And because the environment and the agentic artifacts in that environment changes continuously, the behavior of human opponents also change continuously. They therefore develop third-party applications to model that environment. Understanding the environment without these third-party applications is too complex. They need to build some type of external software applications to offload some of the cognitive burden that understanding that environment leads to. At the same time, they need a deep knowledge of the world mechanics in order to design those applications. That knowledge comes from individual experimentation with the environment that interacts with what I call a collective sedimentation of knowledge. They build wikis, they record knowledge in YouTube instructional videos, etc., so that they can share knowledge across the entire player community. Now, as they're engaging with this persistent instability in the environment, they're continuously scanning for opportunities to earn in-game money, to gain in-game resources, to do something interesting in the game. And once they've identified such opportunities, they can design opportunity-specific in-world artifacts, meaning the ships that I previously talked about. And then they can tactically execute whatever it is that they want to do, ambushing another player, for example. And the result of such an action then leads to learning. Maybe it was successful and they found a great way of engaging with these types of things, or maybe it was not successful. Then they need to maybe reconsider their tactical execution, reconsider the artifacts, the ships that they designed to compete with their opponents. So what do I learn from this? And these are some of my tentative thoughts. And the first thing I learned is that in algorithmic environments, where there's some type of artificial intelligence that is making decisions, that is taking action in some ways, there is a persistent instability, and that challenges our received notions of sense making as focused on disruptions to normality. You see, in this environment, there is almost as if there is nothing that's normal. What's normal is constant change, constant dynamism, opacity, and an inability for people to predict what the agentic artifacts or the tools, what they're going to do next. I also see that developing of software tools to manage algorithmic environments is crucial. Because these environments are so complex, because the behavior of algorithms and AI tools is often opaque to various observers, we need other software in order to make sense of how such algorithms function and what they're likely to do in various types of situations. And this reminds me of something that Wanda Orlikovsky said a few years back when she had a keynote at either ISIS or AoM, and she asked the question, how are we going to study these algorithms? Well, maybe we need to use algorithms to study the algorithms. And I think, at least in practice, the answer is very similar to that, meaning that in order for practitioners to understand how these algorithms behave, they need to design their own software to analyze the algorithms so they can understand what the algorithm is doing. And last, this changes practices of innovation, because in this game, players continuously innovate with regards to how they set up their ships, how they set up their artifacts, the tactics that they apply. But such innovation cannot be seen in a linear manner. It cannot be seen in a static manner. It's adaptive because the situations that they face change continuously. It's contextual because no single strategy can work in all contexts. And it's non-linear. There's no sort of clear sense of progression, but you constantly have to adapt to the changing environment. So in conclusion, I think what's interesting and what I'm still grappling with is not only the fact that AI tools and algorithmic environments create opacity, but they also create this persistent instability. And that's an interesting challenge for practitioners to deal with that persistent instability, and obviously a theoretical academic challenge for us to describe and theorize the ways in which we can manage the persistent instability of algorithmic environments. So that's a little snapshot in what I'm doing right now. I hope I haven't gone over my time, and thank you so much.